Identify the statements that are true due to the fact that the cosine is an even function. Let's remind ourselves what an even function is. An even function is basically whatever you do on the left side of the y-axis, the right side has to be a mirror image of it, which I probably demonstrated that poorly because I decided to make this weird squiggly line. We know cosine. We know cosine looks like this. Now, I'm not going to go crazy drawing this out, but we know it looks like this, which means the other side looks like this. There's our even function. So the graph of y equals cos theta has a rotational symmetry about the origin. No, that's what makes it odd. The graph of y equals cos theta has a reflective symmetry over the y-axis. Yes, that's what makes it even. Now, you may also remember a fun fact about an even function, that f of negative x is going to end up equaling f of x. Now, what that means from a graphical point of view is if I plug in like negative whatever, negative a, I'm going to get the same exact thing as if I were to plug in regular a. Okay, now what that means in a case like this is if I have basically g of negative x, or let's just say g of x equals cos x. G of negative x means cos negative x. So cos negative x, if these guys are allowed to be the same, is going to equal cos regular x, which is what 3 says. What this guy is saying is the rule for an odd function. What this guy is saying, if I plug in like negative a value, I will get the opposite than if I plug in the positive value. Like if I plug in negative that guy, I would get this guy, but down here, which is not what happened at all. That is the odd format. So 1 and 4 follow odd rules, 2 and 3 follow even rules.